Hello everyone, this is Unofficial Sando. Today I'm going to do machine learning series to show how to implement dropout layer. If you like these videos, you can support me by subscribing my channel or click likes of my videos. You can always find the code in the video description below and all of my video list. So what's dropout? Dropout is one of the regularization methods for neural network. It can help to prevent overfitting. When we talk about the overfitting, we don't want few of nodes in a specific layers learn all of the information. We will assume like the connection between its input to these nodes can be very strong, so only of those nodes learn all the information. Then the dropout can make us to cut off those connections, then to let the other input flow into other nodes. So in left picture here, I show the fully connect network with 3 layers and one set of input and the output. After we implement one dropout, the networks will look like as right picture. We implement dropout in each layer with different probability. For example, for first layers, we tell dropout for 0.6% to keep current node. Then since we have 5, we will shut off 2 nodes. Then the connection between those shut off nodes has been cut off from the input. Then for the second layer, we are set 0.5 probability, so we'll shut off only 1 node. Third layers, we keep all the nodes. One thing to remember, for the input, we generally set as 1.0, so we don't want to drop any input. In these ways, for each training step, we can change the nodes will be shut off. So this is one shot. The second shot may be this one and this one get shut off. So this technology frequently used when input size is large but lack of enough training data, such as computer vision application, because our input image generally have a large number of pixels. If you have enough training data, you might don't need to bother for this technology, because in these ways, we are adding the randomness, make it harder to check gradient descent performance during your training stage. If that happens, the suggestion is to disable dropout at first training pass. Once you get more stable gradient plots, then you just enable dropout to prevent overfitting. Next, let's see how to implement dropout in Python. I create a class for dropout, so this should be applying for each layer of neural network. Then I define a mask, so basically to tell which node should I turn off or turn on, and the probabilities shows in previous slides. In the forward, I take the input of as X and the training mode. Once the model is training, I start to instantiate the mask. The mask is created by fetch from the Bernoulli distribution. Then here, the first arguments I given binomial is 1, which means the Bernoulli distribution. Basically, here it says if I flip a coin, then there is p probabilities I get a head, and 1 minus p I get from tail. So if I flip once, what's the expected values I have obtained for this event? I also pass into the input dimension. In that sense, I just, for each value of the dimensions, I just flip once and see what's the value of that. Then eventually I will get a mask with kind of one hot, not one hot, it's like uh, array with the binary numbers. Next step, I'm going to scale the weights based on the probabilities. The reason is that if you still remember previous networks, for example, if we have five nodes, then assume each node has a weight 1, right? Then our output is kind of expected of 5 kind of stuff. Then if we implement dropout to dropout 2, then our output will become 2, 3. However, we want to maintain this scale or expected value after implement dropout. So we want to rescale those weights to keep the expected value. So what we can do here is increase 1 to something bigger, right? So this, say I do 1.6, 1.6, then after we implement dropout, we come 4.8 something. So it's very close to 5 in that sense. And this technology is called inverted dropout. We scale the weights to maintain output expected value. And after this step, we obtain our mask. So we apply those on the input to change the output. Then in the validation or testing side, we don't need to do anything. We just directly pass the input to the output without dropout. It's also straightforward to back forward. We will just apply the mask onto the output gradient, then which means we don't want to update the shut-off nodes during the backward. And luckily, we have a mathematical theory support for this technology. I posted this article here in the towards data science. You can learn more details. What's the theory behind of dropout? They also talk about the inverted dropout in the article. And very interesting, I found this article as well. It mentioned a different dropout is called Gaussian dropout. In our previous implementations, we can think about the dropout is just the gate, right? So we have input here to the node, and then the gate here is determining whether we want this input to pass through or not. In previous implementation, we implement the Bernoulli's distribution here. Then people also find out the Bernoulli's distribution can be replaced with the Gaussian distribution, and this is called a Gaussian gate here. I'm not going into more details about this. You can refer the previous article to see more details. But I definitely recommend you to check out. There's an advantage to use Gaussian dropout against with the Bernoulli's distribution. Yeah, so take a look and see whether the Gaussian dropout is a more fit for your application. Yeah, that's all I want to talk today. And if you have any questions, please feel free to leave it as video comments. I'll see you in next video.